All right, chapter 1, section 6 is called inverse functions. So we're going to learn all about how to test that something is an inverse function and then how to find it. Notice we're talking about functions, so all the stuff about functions is going to carry over. The same test that we use for functions you'll see kind of come into play today when we're dealing with, God bless you, with the inverses. So the first thing you're going to do is verify that something is a function. It is an inverse to a function. And this is how. If G is the inverse function of the function f, then f of g of x, so the composite function, will equal x, and then g of f of x will also equal x. And we show that something is a function to another function by replacing the original f of x with f negative 1 of x. So that's your little subscript negative 1. That's saying that that is the function's inverse. All right, so the directions say use the inverse function property to show that f and g are inverses of each other. So this inverse function property is basically just saying that you want to take f of x, plug it into the g, and then g of x and plug it into the f. So you're going to do it twice. And show that both of these equal x. So you're proving that one is the inverse of the other. And to do that, you have to do both of those things. So I'm going to do the first one, right? So it gives me f of x is x minus 6, and g of x is x plus 6. So the first thing I'm going to find is f of g of x. I'm going to take the g, plug it into the f. So x plus 6 minus 6, and the 6's cancel, and I'm left with just x, which is what you should get. G of f of x means take the f of x, plug it into the g. X minus 6 plus 6, 6's cancel out again, and I get just x. So just like when we're verifying, okay, your work is your answer. So it's telling you they're inverses of each other. You should get x at the end. But your work is going to be your proof. All right, so first thing I'm going to do is take the g of x, plug it into the f of x. So underneath the x plus 3, then it would get squared minus 3. Square root of x plus 3 squared is just x plus 3, and then x plus 3 minus 3. Those cancel, and I get just x. Same thing in the reverse. So now I'm doing f of x into g of x. So I get the square root of x squared minus 3 plus 3. These cancel. I get the square root of x squared, which is just x. It's actually the absolute value of x, but we'll talk about that in a minute when we come back to your restrictions, like why that is okay. I'll come back to that slide in a couple of minutes. But basically, your work should be your justification that those are inverses of each other. Everybody good? All right, so 1, you should have gotten square root 41, square root 65, and then 3 square root 2. Again, remember that when you're giving me the length of the sides, it's got to be simplified square root format. So that square root 18 had to change. But then if you compare them all, they're obviously not all the same, which means not equilateral. 2 of them weren't the same, which means not isosceles. And then when I did a squared plus b squared equals c squared, I got 59 and 65, obviously not equal, so it's not a right triangle either. Questions on that one? 2, center, and I picked totally random numbers and then got something easy for my center. So just be careful, be prepared for fractions that could happen. All right, you should have gotten x minus 1 squared plus y minus 1 squared equals 13. 3, find the intercepts, the symmetry, and then graph the equation. So your intercepts, which need to be in point format, -5, 0, and then 0, 5, and 0, -1. And the symmetry was none. Not x-axis, not y-axis, not origin. And then if you've got at least the 3 points, you could graph if you know what it looks like. If not, you should insert extra points so that you know what that graph looks like. Number 4, your slope was 4/3. Your y-intercept is 0, -5. Again, in point format. Number 5, the slope is undefined. That is a vertical line. And there's no y-intercept. And 6, the slope, I'll get it. 6, the slope is 0, and the y-intercept is 0, 2. And then 7, y equals -5 halves, x minus 5 halves, and y equals 2/5, x minus 27/5. Okay, functions. So 8 is yes, 9 is no. 10, that 3 should have been a y, kind of a trick question without it, so change that 3 to be a y. And then that's a yes. Christian. Okay. 17 or 11 is no, fails the vertical line test. 12 is yes. The graph of the function looks like that. So notice the blue one has an open dot on where -1, 0 is. That's because it's greater than -1, not greater than or equal to. It has to have an open dot. Otherwise, it's going to fail your vertical line test. And then 14 should have been 2. And 5 should have been 48. Notice that 14 overlaps with your graph. Like if you go to where x is -1, there's a solid dot at 2. So those should both make sense. And then difference. Quotient should have been 6x plus 3h minus 2. So the blue is the work for the f of x plus h. The black is your f of x. Distribute that negative, combine your like terms. Last step is making sure it gets put over h and then simplified. Questions on any of that? So again, I'll post this if you're sitting there with a question and be scared to ask. But obviously, if you've got a question, somebody else might, so I'd encourage it. All right, 17, and I want to pick on 17 for a second, and I want to adjust it and see if you would catch it. So with the top, I set it greater than or equal to 0, which means x has to be greater than or equal to -3. And then the bottom also has a restriction, which is x cannot equal -4. Remember, if it can't work for one, it can't work for the other, but because we've already ruled out -4 in our range from -3 to positive infinity, I don't have to do anything different. If, let's say, that this was an x minus 4 in the denominator, how does it change that? What happens to the restriction on my denominator? X cannot equal 4. So is x part of the range that's there in the green? Like if I say -3 to positive infinity, is 4 in there? Yeah. So if this happens, then you have to change it so that it goes from -3 up to 4, but can't include 4, and then starts at 4 again and goes to positive infinity. So if your not equals falls within the range that you have from your other one, you have to make sure that you account for it. Does that make sense? Everybody understand that? Yeah? Okay. 18, there's no restriction. There's a number in the bottom, but it's not a variable. And then 19, 20, 21, 22, and 23 are all based on this graph here. So it should look something like this. This is the only part of your test you're going to get given a graphing calculator on. And you won't be able to do it without it. It's not something you can graph without your graphing calculator. If you use the app to graph it, which is totally fine, just make sure you know how to graph it on your handheld device, because you're not going to have your iPad as part of your test, okay? You're going to have your graphing calculator, which means if you forget your graphing calculator, and I'm pretty sure it's almost set up the same way, that's like 5 questions wrong on your test. You could try to plot points and figure out what it might look like, but it's going to be really hard to find your max and min. So be careful. Make sure you have it with you. So domain for this and range were negative infinity to positive infinity. The arrow is pointed in both directions. Increasing, and remember it's your x values. So it was increasing from negative infinity to negative 1.4. If you're within a couple of tenths of a point, it's okay. Okay, but you want to be pretty close. And then it increases again from 2.1 to positive infinity. All of those are parentheses. Decreases from negative 1.4 to 2.1. The zeros were at 3, negative 3, and positive 1, everywhere across the x-axis. And there's a max at negative 1.4, 16.9, and a min at 2.1, negative 5. Both of those are in point format. And neither even nor odd, okay? It wasn't symmetric to the x-axis or the y-axis.
So for the zeros, we don't have to write it as point format?
No, you can give it to me. I would have taken it either way, but you can give, that's the only time, because you're saying, what are the zeros? Where is f of x equal to 0? So you already know that it's 0, and that's where those places are. Like when we start solving the, functions for 0, you'll give it to me as an answer like that. All right, so 1.4, your graph should have looked like that. Notice that I wrote on there stretched or flat. Could have been narrow, tall. Okay, for the first one, could have been shrunk. For 25, you've got to at least make sure that you identify that it was different than your normal. Your domain on 24 is negative infinity to positive infinity for both domain and range. For 25, your domain 4 to positive infinity. And your range, because that points down, that should have been upside down, is negative infinity to 2. Bracket on the 2 and the 4. And then 26, 27, 28, where you're combining your functions. So 26, f of g of x should have been the square root of x minus 2. 27, g of f of 12, sorry. Take the 12, plug it into the f, you would have gotten 9. Take the 9, plug it into the g, and you get 4. And then 28, f plus g of 16 means find f of 16 plus g of 16. F of 16 was 13, g of 16 was 5. Add those together, you get 18. You could have also done it like first combine your equations. So if I had done f plus g of x, it would have looked like that. And simplified it if you wanted. Like I could have kept going here. I could have said x minus 2 plus the square root of x. And then plugged in the 16. You'll get the same answer. 16 minus 2 is 14. Plus 4 is 18. Okay? You can get the same answer either way. So it's up to you how you do that. But f plus g of 16 means f of 16 plus g of 16. Christine?
Like for the square root of 16, you would do like positive 4.
No, it's so funny. The same exact question came up in the last class. So the only time that you do a plus and minus on a square root is if you have a variable raised to an even power set equal to a number. When I go to solve that, that's the only time that I can really take two answers. If I go to solve that, it's saying, what can I plug into x to get that number, right? So let's say this was 9. So to get 9, I can either square positive 3 or I can square negative 3, right? But if I am square rooting 9, the answer is just 3. So the only time I introduce the plus and minus is if I've got a variable raised to an even power and I go to solve it. Does that make sense? Okay, so anytime you're just square rooting, you want to make sure that it's just the positive version of that number. Questions on any other review or 1.6? Keely?
Can you go to number 25?
25, yeah. No problem.